We're going to expand your knowledge of identities to include addition and subtraction identities for the trigonometric functions that have a lot of utility. We're going to prove the angle addition and subtraction formulas for cosine. And we're going to do this in a similar fashion to sine, so if you haven't seen that video, you probably ought to watch that screencast first. We're going to prove that the cosine of alpha plus beta is equal to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. The cosine angle subtraction formula follows in a similar fashion, so we're going to move that off to the side for now. So we're going to draw a similar triangle setup to what we had to prove the sine angles, because we are trying to find alpha plus beta's cosine ratio this time. Now you'll recall that cosine is adjacent over hypotenuse, so if this giant angle here, CAB, is equal to alpha plus beta, its cosine would be equal to its adjacent side, which would be AC, over its hypotenuse, which would be AB. For the cosine of alpha plus beta is equal to adjacent over hypotenuse, segment AC over segment AB. Using segment addition, we know that segment AC is equal to the big segment here, segment AF, minus this little part here, CF. And since CF and DE are parallel to each other, they are equal in length. So another way to write this is AC is equal to AF minus DE. Therefore, if we substitute AC, which is equal to AF minus DE, for the AC up here, because they're the same thing, we get, combining these two ideas, that the cosine of alpha plus beta is equal to AF minus DE divided by AB. So this can be written as AF over AB minus DE over AB, because they're the same thing. This is going to get us closer to the trigonometric ratios we're looking for. So as before with the sine, we're going to multiply AF over AB by AE over AE in this case, because AE is a part we know. And it doesn't change it because, again, AE over AE is just 1. But if we multiply it and rewrite it, we get AF over AE times AE over AB. And this multiplication of the two ratios is exactly the same as this ratio. In a similar fashion, DE over BE times BE over AB is the same as the second ratio here. We've multiplied the top and the bottom by BE. And in doing so, we get 4 trigonometric ratios that we can use. Let's look at the first one, AF over AE. Since AF is the adjacent side of this light blue triangle and AE is the hypotenuse, we know that AF over AE is the cosine of alpha. So the second ratio, AE over AB, comes from the pink triangle, the pink right triangle, and AE is the adjacent side, AB is the hypotenuse, so adjacent over hypotenuse is cosine, it's the cosine of beta. The cosine of beta is equal to the adjacent over hypotenuse, AE over AB. So now we've got these first two terms. Cosine of alpha is AF over AE, cosine of beta is AE over AB. Let's get the last part. Now for the last part, we're going to, for DE over BE, this third ratio, we're going to concentrate on this dark pink triangle here, triangle DEB. But we've got to find this alpha, we've got to find this angle up here. If you remember from the sine proof, this winds up being angle alpha up here at the top, angle DBE. And you do that because DE and AF are parallel lines cut by a transversal, so this angle alpha here is also the angle right here. And if that angle alpha equals that angle alpha, and this is a right triangle at BEA, then alpha and this angle inside this right triangle at the bottom right are complementary. Therefore, if they're complementary, and the angle at D is a right angle, then the angle up here at B is angle alpha also. So if that angle is alpha, then the ratio of DE to BE is opposite to hypotenuse for this angle alpha, so it is the sine of alpha. So DE over BE is the sine of alpha. Now focusing on the pink right triangle, which is formed by angle beta, the ratio of BE over AB, well, BE is the opposite of that pink triangle, and AB is the hypotenuse. Therefore, this is the sine of beta. And we now have our fourth term because BE over AB, opposite to hypotenuse, is the sine of beta. And now we've put together the angle addition formula for cosine. And that is that the cosine of alpha plus beta is equal to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Notice the only difference from the sine is, well, there are two differences from the sine formula. First of all, the signs are switched. For positive, it's negative. Secondly, instead of sine cosine or cosine sine, it becomes two cosines at the beginning and two sines at the end. And you've seen why, but it's helpful to understand that. So now we can put them both together, the angle addition and subtraction formulas. And the same thing works for the subtraction formula, same idea. If we made the big angle alpha and we kept beta the same, then the blue angle here instead would be alpha minus beta. Everything would work the same except the signs would again be flipped. Angle addition and subtraction formulas for cosine, you've now proven. The cosine of alpha plus beta is the cosine of alpha cosine of beta minus the sine of alpha sine beta. The cosine of alpha minus beta is the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta.